All right, for round 2, we have Chapter 8 now. Chapter 8 is hypothesis testing. So we're going to do hypothesis testing of proportions, means, standard deviations. So I wanted to go through this worksheet assignment in class activity, hopefully to help iron out any questions or maybe troubles you have. And we'll talk about diagnosing and understanding problems and hopefully figuring out what pieces of information are important and how you should be able to use those. Again, hopefully you've already done this before. I would recommend that you do. That way it makes more sense that maybe you struggled and you had a little bit better understanding. Otherwise, if I just tell you this, you might, assume that you know it and might not retain it as well. Needless to say, without further ado, let's do these problems. So, first question is, suppose you randomly polled 2,456 citizens of Laramie and found that 56% said they had a bachelor's degree or higher. All right, off that first sentence right there, we have two pieces of information. Polled, meaning it's a sample, okay? N is 2,456. That 56%, that is your p-hat, okay? So you might want to write those kind of pieces of information down. So you know that p-hat is 0.56. You know that n is 2,456. So right off the bat, you should have an idea that we're probably talking about proportion. So that's going to help you figure out which population parameter we're using, whether it's the mean, the proportion, or the standard deviation. Okay, the next thing is find the critical value if the U.S. Census Bureau claims that 24.7% of the state of Wyoming residents have a bachelor's degree or higher. Okay, right off the bat, we talk about hypothesis testing. There's always going to be something called a claim. Now, generally speaking, the claim should always be in the alternative. But if it has equal in it, then it becomes in the null hypothesis. Okay, so anyways, first it says if the level of the significance is alpha of 0.1. So we need to find the critical values. So in this case, you need to find z of alpha over 2, which means that you're going to find, how do we find the critical values when we're doing hypothesis testing? Let's back up a second. So first thing we probably should do is figure out alternative hypothesis, because this is going to tell us whether it's right-tailed, left-tailed, or two-tailed. So in this case, we're talking about P, right? Population proportion. The claim is that 24.7%. So claim is always equal. In this case, not equal would make that false. So 0.247 and equal to 0.247. Okay? That is your alternative and null hypothesis. This is your null. This is your alternative. Okay? Now, the reason why I said we need to do that probably first is this tells us whether it's, in this case, it's two-tailed. If it was less than, it'd be one-tailed and be left-tailed. If it was greater than, it would be right-tailed. Okay? So, in this case, that means for our critical values, we need to find those cutoffs here and that cutoff here, which means that you should have 0.05 here and 0.05 here. In other words, those two added together give you that 0.1 that we're looking for, okay? So, you should find, if you have your table like this, right? By the way, what distribution are we going to use? The standard normal, because we're using proportion. All right. One thing you can do, which is kind of nice too, is if you get tired of always trying to look and doing, 0.95 to figure out that, you can also look at this, and you know that this is symmetric. So if you find where this oops, you can't see that. I'll move that up. You find where this is 0.05 and 0.0495. So right between those two is where we find our 0.05. That's negative 1.645. So that means this value right here is negative 1.645, and it's symmetric, so this should be 1.645. That is our critical values. So if you're asked that, you'd say negative 1.645 and 1.645. That's basically your cutoff between those bounds. All right, next one is write a null and alternative hypothesis. Well, we did that right here. I know this is a little sloppy, sorry. You should probably make it more room when you do your answer key. Next one is make a conclusion about the results. Well, we can't make a conclusion about the results until we do what? We need to find a test statistic. So, try to keep this straight. Need test statistic. Well, statistic. All right, so that means we're going to do z is equal to, we'll have p hat minus p divided by and what goes down here is the square root of p times q, not p hat, by the way, p and q. And then that should go all the way down. Put parentheses around that. Orders operations, do this inside part first, then take the square root of it, and put parentheses around that, and you should be able to find that. So in this case, we're going to fill all that information in. Let's fill that in. I want to do it over here. So z is equal to 0.56 minus 0.247 divided by the square root of 0.247 times 0.753, all divided by 2,456. That'll give you z of 35.96. Oh, 35. That on our scale would be way out here. So that is in the shaded region, even though it's way out here. So you reject the null in favor, of the alternative, that it's not equal to it. And that kind of shows their support, right? That this is different. Okay. So hence we reject the null in favor of the alternative hypothesis that is not equal. All right. Now, in D, it says, now suppose we make the claim that less than 56% of the population has a bachelor's degree. All right. So what we're doing here is we're just changing the critical values, basically, because the null and alternative changes. The claim is now less than, right? So P is less than 0.56, and P is equal to 0.56. What's kind of ironic about this one is that you're going to end up with z is equal to 0.56, which is p hat, minus the null part, 0.56, over, well, the same information. But this is here is 0. So in this case, we'd fail to reject. If you notice that the z-score would be 0, which means it would lie right here, which is the fail to reject region. Okay? All right. So what happens if the critical values change? Suppose alpha is 0.05 or 0.01. That just adjusts these ends, right? So if it gets smaller, which is what both these do, right? That means the area in the tail gets smaller. In other words, the values get pushed out further. So the right side will probably be greater than 1.645. In fact, 0.05, I think that gives you 1.96, and it'll be negative 1.96. And 0.01 should give you negative 2.575 and positive 2.575. Okay. But as it pertains to this problem, either way, all it does is make the rejection region smaller and therefore makes the confidence of your estimate stronger. Okay. Number 2, M&Ms and aspirin. A package label includes a claim that the mean weight of M&Ms is 0.8535 grams. Another package label includes the claim that a mean amount of aspirin in Bayer tablets is 325 milligrams, which has more serious implications: rejection of the M&M claim, rejection of the aspirin claim. Is it wise to use the same significance level for hypothesis testing of both claims? A lot of you might be just screaming out loud right now, like, this is obvious. You do not want to have this be off. Why? Because this could be something that would cause people take aspirin sometimes, right, to alleviate heart attacks or maybe pain. Basically, this has more implications because it can be more harmful to society. Okay? All right. Number 3, we have claim. We have the Center for Disease and Control Prevention claims. So if you're reading this right off the bat, you see claims. So you should know right away that that's going to be part of your null and alternative hypothesis. So you're going to have a null and your alternative. All right, that 34.9% of Americans are obese. Okay, this right here is a proportion because you see it. All right, this is the claim. So it's that it is equal to it, right? So that basically means, so if we're going to go back, especially original claim in symbolic form, this is saying that P is equal to 0.349. So what would make that false? Not equal to. By the way, in your null hypothesis, you should always have equal. If a poll of 87,650 randomly selected American citizens showed a result that 45% of them were obese, okay, poll, there's your hint there. And we just take those pieces of information. So N is going to be 87,650, and P hat is going to be 0.45. Okay? And what we basically need to do now is come up with our test statistic so we can figure out whether we're going to reject or fail to reject. So in this case, our null and alternative, we have that. So what's nice about this is this tells us two-tailed. So that means we need to find two. It's a terrible test. Sorry, the distribution was really not well drawn. But it tells you we're going to use the normal distribution because we're using proportion. It tells us it's two-tailed. So remember the critical value? All right, so in this case, it says find the critical value if alpha is this. By the way, if you're not given a critical value, a lot of times it's assumed alpha is 0.05. So that means you're going to have 0.025 here and 0.025 here, which means that this should be 1.96 and this would be negative 1.96. Now you might be wondering, how do you get that? Where does that come from? Again, it's two-tailed and we want to find that area in the tail. So if you're using this and you want to find the left side, you'd want to find 0.025, and you see it's right there. And you see negative 1.96. Right, so if you go all the way up here, that's the value you get. All right. So we found the critical value. Now find the 99% confidence interval. So we want to find the confidence interval just like we did last time before. We just find our margin of error. Just to make sure you guys get the same values, you should get 0.446 and 0.454. Okay. Now, I can show you how to do all these things on your calculator, which is really nice, but you've got to be able to understand whether we're talking about a proportion, a mean, or a standard deviation. Those are the important things you've got to be able to pick away from these questions. All right. Number 4, we have community involvement claim. 3/4 of all adults believe that it is important to be involved in their community. Based on the USA Today poll, 1,021 randomly selected adults, 89% believe that it is important to be involved in their communities. Okay, so right now we have 2 pieces of information, 3 pieces of information. Actually 4, if you think about it. You guys would probably tell me, obviously we're talking about proportion, right? N in this case is 1,021. P hat is 0.89. And the claim is 3/4. What is 3/4? 0.75. So in other words, that's what P is. And that's the claim. So why is it important to find this? Well, basically it says find the test statistic. Well, remember, this is a normal distribution because it's proportion. So we're going to have P hat minus P divided by the square root of P times Q divided by N. So in this case, 0.89 minus 0.75. Right? P hat always goes here, P goes there. And then when we have this, it would be 0.75 times 0.25 divided by 1,021. Take the square root of that. And you should get 10.33. And that is your test statistic. Now, this test statistic is great, but you need more information if you're actually going to test this and figure out whether you reject or fail to reject, because you need to figure out an alpha value you want to use and what you're trying to solve. Okay, number 5, we have white blood cell count claim for adult females. The mean of their white blood cell count is equal to 0.8. The random sample of 40 adult females in data set 1 from the appendix has white blood cell counts with a mean of 7.15 and a standard deviation of 2.28. The population standard deviation sigma is not known. That's in parentheses for a reason to tell you that. So you know, if we don't know sigma, we use the student t distribution, we're talking about the mean. Okay? So in this case, we're using t-distribution, so our test statistic comes from the student t-distribution, we'll have x bar minus mu divided by s over the root of n. Okay, so what is x bar in this case? X bar is 7.15, right? Because it came from a sample, and that's that, minus mu, which is what the claim is, right? 8.00. And then we're divided by 2.28, which is the sample standard deviation, S, and then the sample size, which is 40. And you should get negative 2.358. Okay, again, the key parts there is not necessarily the number we get here. I mean, it is important, but it's to understand that we're talking about mean. We don't know the population standard deviation, so we're going to use the student t-distribution. Okay. All right, so number 6, assuming a significance level is 0.05, find the p-value and the critical values. So it's really easy to find the p-value when we have the normal distribution. It's a lot harder when we have the student t. In fact, you might just find a range of values. So the test statistic of z of 2.00 is obtained when testing the claim that p is greater than 0.05. So why is this important? That's the claim, which means this is going to go in the alternative hypothesis, right? Only because its p is greater than 0.5. Oops. Period goes there. That means it is right-tailed. So that means our critical value should be positive. Okay? And we know it's one-tailed, which means alpha of 0.05 is this area right here. So we go to our table. And we go to positive, right? And we're going to look for 0.95 up to that part, because that'll give us our critical value. And you see it's right there. And it looks like 1.645 is our critical value. Now, where does our test statistic lie? Z is 2.0. It lies right here. So that is where our test statistic lies, Z of 2.00. That means we would reject in this case, okay? All right, let's go through the next couple. The test statistic is negative 1.75, obtained when testing the claim that p is equal to this. So we're going to have p equals 1/3, and p does not equal 1/3, right? So null, alternative. Again, always in the null is equal. All right, so in this case, it's two-tailed, which means we're going to have 0.025 in this side and 0.025 in this side. So if we go over here, we can find the negative side first, because this will tell us right away. 0.02 right there. We see negative 1.96. So that means right here will be negative 1.96 and positive 1.96. Those are our critical values. Now that determines whether our test statistic we either fail or reject. Now if you look at this test statistic, it would lie right here. So that's where your test statistic lies. And so that would be in the fail to reject region. Okay. I'm just going to write down the next couple of answers so that way you have them. C, we have p-value. Oh, yeah. How do we find the p-value? Sorry, I skipped through that. So the p-value part, you find the test statistic that corresponds to it and then go back from it. So in this case, for A, we have the test statistic is 2.00. So if we were to go here, and we know it's right-tailed, so we have this. Go to 2.00. You'll see you have this value right here. That means that it's 0.9772 to here. But that means this area right here is your p-value, which in that case is going to be p-value is going to be 0.0228. That is your p-value. Okay. You do the same thing for 6b as well. So we look to the negative side, right? And we figure out which tail it is. By the way, it is two-tailed. So this is a little trickier. So you get negative 1.75 is right here. And you see 0.0401. So you tell me, oh, that's this, 0.0401. Well, when it's two-tailed, we double that. So it's 2 times 0.0401, which gives us 0.0802. Now you realize if we were using the alpha method of doing the rejection, if you said that value, you would reject. In this case, you'd say fail to reject, which agrees if you did the critical value method over here. Okay? So sometimes you can double check those things, which is really good for you. All right. In C, we have the p-value should be equal to 0.0013, and the critical value you should have is negative 1.645. That's period. And in D, we have the p-value is 0.0124, and the critical value is negative 1.96 and positive 1.96 because it's going to be two-tailed. All right. Two-tailed because of this part. All right, 7. We have the original claim. The percentage of blue M&Ms is greater than 5%. The hypothesis test results in a p-value of this. Use a significance level, right? State a conclusion about the null hypothesis, reject or fail to reject. Okay, so a lot of times I don't want you to just write fail to reject or reject the null. That's not going to get you the answer, okay? I need you to be able to understand what you're saying when you do it, right? So that's going to be the B part here. Without using technical terms, state a conclusion that addresses the original claim. So in this case, we look at the p-value and how it compares to alpha. So is it less than? Is it greater than? Is it equal, right? So depending on which way that goes is how we either reject or fail to reject. In this case, you see that the p-value, 0.001, is less than the alpha value. In this case, so p-value, alpha value, we reject. Because we go back up here, if you think about that, that means it has a smaller area. Okay? So reject, no. Now, what does that mean in terms of layman's terms? Well, there is sufficient evidence then to support the claim that the percentage of blue M&Ms is greater than 5%, right? Because that's the claim, which became is greater than, right? So if you're going to write that as your null and alternative hypothesis, right? Null is that it equals, proportion, 0.05, and the alternative is that it is greater than 0.05. So you are rejecting the null in favor of the alternative, and that it's greater than it, okay? 8, we have fewer than 20% of M&M's candies are green. The hypothesis test results in a p-value of 0.0721, using alpha of 0.05. Okay. Well, in this case, you see that your p-value is greater than your alpha value. So 0.0721 is greater than your 0.05. So you fail to reject. So what does that mean? Well, that means there is not sufficient evidence to support the claim that fewer than 20% of M&Ms are green. So once again, that is, there is not sufficient evidence to support the claim that fewer than 20% of M&Ms are green. In other words, because we failed to reject the null hypothesis, we can't give support to the claim. Okay. Number 9. We have guns and homes in a Gallup poll of, by the way, this is actually in your text. It's number 6 for section 8-3 if you're having the 12th edition. In a Gallup poll of 1,003 randomly selected subjects, 373 said they have a gun in their home. The accompanying mini-tabs display shows results from a test of the claim that 35% of homes have a gun in them. Interpret the results. In other words, use the table to make 4 inferences about the hypothesis test and just hypothesis and tests. All right. So in this case, one thing you could say, A, two-tailed. How do I know it's two-tailed? This part right here. P is not equal. Okay? B, second piece. We can figure out the test statistic value. Z equals to 1.45. That's this piece right here. Okay? I'm saying C, these should be numbered. I mean, if you're asking for 4 inferences, but we know the p-value, 0.146. That's the piece right here. D, we know that we would fail to reject the null hypothesis because the p-value is greater than the alpha value we might select. By the way, how do we know the alpha value? Right from here. Sorry. And then you could also get some of the other summary stats like X and N, those pieces of information. Sample P, in other words, P hat. All those pieces of information are provided there. How would we say this now? If we go back to the whole idea of fail to reject the null, I don't understand what that means. So let's talk about it in terms of something a normal person might say. So you might say there's not sufficient evidence to warrant rejection of the claim that 35% of homes have guns in them. So, not sufficient evidence to warrant rejection of the claim that 35% of homes have guns in them. In other words, this likely could be true, so we can't reject it. Okay? All right, number 10. We're going back to M&Ms. We have a data set. 100 M&Ms, and 8% of them are brown. Use the significance level to test the claim of Mars Candy Company that a percentage of brown M&Ms is equal to 13%. Okay, so let's write down all the pieces of information we know right off the bat. Well, we want to construct our null and alternative hypothesis. All right? So in this case, what are we talking about? Are we talking about proportion or are we talking about a mean? 8%. Proportion, right? So we're going to have P, right? Okay, and this is sample data, right? It's right here, right? So N is 100, P hat is 0.08, and use significance level, so this is going to be 0.13, right? Percent R or is equal to, so not equal. All right, so we got those two pieces of information. Why am I doing this? Because I want to show you on the calculator how you can do this kind of problem too. So we're going to go to stats. So go back to stats right here. Your calculator might be a little different, so you might want to do some Googling. I'm sorry that light's getting there. Tests, and in this case, we're going to do a z-test because it's proportions, and so it's a 1 proportion z-test. Hit enter there. It's going to ask us for all those pieces of information. So P0 is corresponding to the null P that you have. So 0.13, and now by the way, if 8% of 100 is 8, right? And 100, and this case says prop, and it says not equal to P0, less than P0, greater than P0. In this case, it's not equal. And we go down to calculate. And as you can see, this spits out all the nice information that we need. Hopefully there's no glare. Bummer. So as you see, we have proportion does not equal 0.13. That's what we're testing. We have a Z, which is our test statistic. And then we have P. And then we have P hat. This P is not the proportion, by the way. That is the p-value. Okay, so in this case, your test statistic is negative 1.49. We'll do because we'll round up, and p-value is 0.137. Okay. Now remember, this is basically greater than alpha, right? Alpha. No matter what alpha value we pick, other than if we pick like 15% or 20%, right? But in this case, it's greater than alpha, so that means we fail to reject. Let's double check to make sure that we get that if we've done the old school way of drawing our distribution and finding critical values. It's two-tailed. And what's our alpha value? Let's just pick alpha of 0.05, which means 1.96 and negative 1.96. Where does our test statistic lie? Right here. This is our rejection region. This is our rejection region. So this is where our test statistic is, and we fail to reject the null. All right. Cool. So you might say there's not sufficient evidence to warrant rejection of the claim that 13% of M&Ms are brown. Okay. All right. This is the last page. Oh, yeah. I know a lot of you guys are probably dying right now. We are at 30 minutes. Okay. I'll try to get this done in 10 minutes or less. In a Harris poll of 514 human resource professionals, 45.9% said that body piercing and tattoos were a big grooming red flag. Okay, right off the bat, if you're reading this, you would see 3 pieces of information very important. First one is N. N equals 514. You see this. This is what? Proportion. And in this case, this is your p hat, 0.459. Now if you're wondering, I don't know where the... All right, let's keep reading. We got a couple more pieces of information. Use a 0.01 significance level. That's your alpha. To test the claim. Test the claim. That less than half of all human resource professionals say that body piercings are groomed. All right, so right away you see there it says less than half. Okay, so that's saying less than half, less than 0.5. That is the claim. So what would make that false? P greater than or equal to? Well, you see the equal sign in there, which means this is going to be the null. P equals 0.5. Alternative, P is less than 0.5. That is your null and alternative hypothesis, okay? Now, we want to test this, all right? So what we can do is we can do this on our calculator again. So I assume you get familiar with the test statistics, but you need to understand, again, what we're doing here. What is P? What is not P? You want to write down all these pieces of information, because now, if we go in here and we do one proportion test again, I'm sure there's getting bad glare on that, sorry. Let's see. Maybe that helps. Cool. That helps a little bit. Oh, you can see me now. That's crazy. All right, P0 is going to be the part right here, 0.5. X is going to be the 0.459 times 514. I have a hunch that does not give us a whole number, which is not good, right? Because now if we try to do this and we hit calculate, it's going to tell there's a domain. So let's go back in there. And what you might have to do here is if you round this up to 236, you're going to be off a little bit, right? In this case, it's, by the way, it's less than B0. And you'll see that we have our test statistic and we have our p-value right here. And based on this, we would fail to reject because our p-value is equal to 0.032. That's this piece right here. And our alpha value is 0.01. So in other words, if you're thinking about this, this is where our p-value might start, right? That's our 0.01 area. Well, in order for this to have, oh, by the way, I'm really on the wrong side. It should be on this side. It's left-tailed. Left-tailed. This would be the 0.01, and our p-value would cover area of 0.032, which would be more area. Also, if we looked at a test statistic, right, negative 1.85, if we were to compare that to what we should get for our critical value, we'd find, so let's do that. So let's find our critical value. That means the alpha is 0.01. So if we go to our table, by the way, this is normal distribution because we're doing proportions again. There we go. It's right in front of me. It's between negative 2.3 and, yeah. So I would use negative 2.33 as my critical value. So that's this value right here. And if you were to look at where your test statistic, which if we look at our calculator, we get negative 1.825, and that would be in the fail to reject region. Okay? All right. Number 12, car crash. The claim is that for a measure of standard head injuries criteria in a car crash test, mu is equal to 475. Okay, right there, mu. That should tell you mean. We're doing a test with a mean, okay? And if you notice, we have not been given the population standard deviation, so you know you'd be using the student t distribution. And if we read just a little further, we have the sample size n is 21, and the test statistic is t, meaning it's the student t. And we have that. Now, if we were to go through this, and we looked at this, we have our test statistic. Test statistic is negative 2.242. We want to find our critical value because we can test it that way very quickly, actually. We'll use alpha of 0.05, and the claim is that equal. So that means the alternative is not equal for mu, and mu is equal. Not equal means it's two-tailed, and the student t distribution. So two-tailed meaning that we should have, there's really not enough room here, sorry. 0.025 here, and 0.025 here because it's two-tailed, okay? And really all we need to do is double check this negative side. So, and this is the student t distribution. Hopefully you guys have gotten familiar with it. The reason why they include the sample size is because that's how we can find the degrees of freedom. So in this case, it's 20. 20 is right there. And how much area should be in the, so like if you're looking up here, you have area in one tail and area in two tail. So basically this is if you split it. So in this case, area in two tails should be 0.05. In other words, area in one tail would be 0.025. So if we go down to 20, oh, sorry. Oh, bummer. So up here, we look at this. We have area in one tail, area in two tail. So two tail should be 0.05. Area in one tail should be 0.025. In other words, you have it. Right? That's why it's there. Then we go down to 20. We see 2.086. Okay. So negative, I'm going to use green, negative 2.086 goes right there, which means this is the rejection region, which means in this case we would reject the null that it's equal to in favor of the alternative that it's not equal to that. All right. 13, we have Oscar-winning actresses data set 11 in Appendix B. List age of actresses when they won Oscars, and the summary statistics are N is 82, X bar is this, S is 111.1. Use a significance level to test the claim that the mean age of actresses when they win the Oscar is 33 years. All right, so in this case, we need to come up with our null and alternative hypothesis. Null alternative. So in this case, mu is 33. Mu is not equal to 33. And hopefully, you get a test statistic that's going to be coming from the student t distribution. 2.367. Why is it coming from the student t distribution, you might be asking yourself? Well, that's because you're not given the population standard deviation. You're given S, which is the sample standard deviation. Okay? So it's going to come from the student t. If you were given that, it would come from the normal distribution. Okay, this is really important because if you want to use your calculator, you report the wrong one if you don't know which distribution to be using. All right. Now, when you do the test statistic, you get that. Your p-value is going to be greater than, is 0.0204. Okay, this is our significance level, which means we fail to reject because the p-value is greater than your alpha value. In other words, 0.1. So you fail to reject. So you fail to reject that it equals 33. So in other words, there's not sufficient evidence to warrant the rejection of the claim that the mean age of actresses when they win is 33 years old. Okay. By the way, the critical values should be plus or minus 2.639. Now you'd be saying, how do I find that? Well, significance level of 0.01, which means you would have that area in one tail, right? So we go here, and the degrees of freedom is based on the number there is. So there's 82. So in this case, I'm going to round down to 80 just to make our lives a little easier. And you see that we have 2.639, okay? And so that's what we would use for our critical value if you're using this table. If you have one that goes to 81, that'd be perfect, okay? All right. Number 14, we have the age of race car drivers listed below are ages of randomly selected race car drivers. Use a 0.05 significance level to test the claim that the mean age of all race drivers is greater than 30 years. Okay. All right. Null alternative. Okay. First thing we're doing is we need to figure out what they're talking about. Mean. Okay. They're talking about a mean. So that's how you know whether we're going to be using normal distribution or the student t distribution. In this case, you're going to be using the student t. Alpha in this case is 0.05, and the claim that the mean age of all race car drivers is greater than, so mu is greater than 30, mu is equal to 30, is going to be the null. And once you have that, the best thing you can do is to take all these pieces of numbers and you can throw them into stat and put them into edit and put them in a list. So you list them all out. You get your summary stats and you can test them that way. If you want to use your calculator, all right, so let's do that. Show you this one on the calculator. So stat, tests, what kind of test are we doing? Well, here's what we need to know. Do we know sigma? Sigma not known. Use student t. Okay, so we're doing a t-test. T-test, and I didn't put it all in there, so we're going to have to put those in there real quick. So stat, edit, put it in list 3. We have 32, 32, 33, 33. $15. Yep. All right. So we have all that in there. Stat, tests, t-test, data, second L3, and mu0 is what you're comparing it to, 30. And in this case, we're doing it's greater than 30, and we'll do calculate. And you arrive at the following. So how do we use this information? Well, we now have our test statistic, which is t equals 1.82 we'll use, and the p-value is equal to 0.045. Now, based on that, you would see we reject the null hypothesis because the p-value is smaller than the confidence level. All right. Moving along, we have number 15. Heights of supermodels listed below are the heights inches for simple random sample of supermodels. Lima, Bunchell, anyways, all the names. I use a 0.01 significance level to test the claim that supermodels have heights with a mean that is greater than the mean height of 63.8 inches for women in a general population. Given that there are only 10 heights represented, can we really conclude that supermodels are taller than women? So this is where we have a very small sample, so it's wondering whether we can do this. And so we might be thinking, well, we took from a normally distributed population, right? We would assume, but this is a specific subgroup, so maybe this would be a little challenging, but let's go through it. So first thing we need to do is talk about our null, an alternative, and what we're talking about. In this case, we're talking about mean, mu. So mu is equal to 63.8. Oh, no. All right. Mu is equal to 63.8, and mu is greater than 63.8. In other words, saying they're greater than that height. Now, the next piece of information, hopefully you'll be able to find your test statistic should be 23.824. And the critical values, if you're going to check these, would be 2.821. And by that should be t. And the p-value is going to be less than 0.005. And if we find it on technology, they might tell you something like 0.00000 plus or something. In other words, meaning that's very small. Just something you'd be aware of. So in this case, we reject the null, and there's sufficient evidence to support the claim that supermodels have heights with a mean that is greater than the mean height of 63.8 for women in the general population. We can conclude that supermodels are taller than typical women in this case. All right, let's move on to 26, last one for this. Ooh. Okay, blood pressure uses systolic blood pressure measurements for females listed in data set 1. Right, test the claim that the female population has a mean systolic blood pressure less than 120 millimeters of hemoglobin. I don't know. Use a 0.05 significance level. If you test this out, hopefully you'll be able to find this is what you have. Mu is equal to 120.0, and the alternative is that mu is less than 120 millimeters. Your test statistic should be t is equal to negative 0.424. Critical value for t is going to be negative 1.685 because this is left-tailed, and it's one-tailed, right? One-tailed. All right. And that's our test statistic. That's our critical value. If we're comparing those two, which I think is really quick, you'd find that your test statistic is here, negative 0.424. That's your test statistic. And your critical value lies right here, negative 1.685, which means this is your rejection region right over here, which means it's in the fail to reject region. So how would we reword that? You might say there is not sufficient evidence to support the claim that the female population has a mean systolic blood pressure level less than 120. Okay. Whew. Done with that one.